The next segment of the show is the Floorbot Challenge. What is a Floorbot? A Floorbot is a robot that's too big for the cable. Thank you. Phase 1, 2, 3. Phase 1, 2, 3. Phase 1 is just to get from one end of the room to the other and back. Phase 2 is to find an object in the room, and Phase 3 is to fetch that object. So, I'm going to have to do 2 clicks. Okay, I apologize. Here's Locomo, the smart table. The concept is a robot that can deliver, do telepresence, and it has AI. So you talk to it, and it talks back to you. Hey Google, what is the Homebrew Robotics Club?
Sorry, I don't understand.
That sounds right.
Okay, Google, what does an elephant sound like?
An elephant sounds like this.
Okay. So anyways, I use the Nito BotVac robot vacuum cleaner as my base. It features a LiDAR, a laser radar, and you can use the Ross package created by our own SV Ross group and a number of folks around here, including Ralph Gnock. I'll pronounce the G out of respect. There he is. And so anyways, the cool thing about Ross is with the robot vacuum cleaner and a computer, I can drive around and I can make this map. I just drove back and forth and created this map. Now, you save the map before you load in the navigation routine, and I've loaded in the navigation routine. So, and I'm not going to bore you to go all the way to the end of the room. Actually, I'm going to try to go all the way to the end of the room. Let's try this. So I'm basically, where's the camera here? Oh, you can see that? Okay, cool. I'm clicking 2D nav goal, click, and I'm going to point, press, and drag over on the other end of the room, mouse up. There's a green line now. It's the path planning. It's telling the robot, whoopsie. Hang on. My demo has gone horribly wrong. Let me back up a second here. There, give me a moment. Now I'm teleoperating the robot, so I'm stopping it. Okay, just hang on one second. Well, no, I'm not going to blame it on battery yet. I'm going to relocalize because I can see where the podium is, and there's an option here to 2D pose estimate. So I'm going to tell him where he is, and I'll say you're right. Whoopsie. He's getting away from me. He's actually heading where I want him to go, so I should just shut up. Okay, so that's the podium. No, I'm going to set his pose in front of the podium there. There we go. Okay, that's more better. Okay, so he's really going to be localized here, but you see the local cost map. You know where the robot is. If I'm lucky, he'll navigate around the podium. Oh, look at that! Yes, you can applaud. Thank you. Thank you. There he goes. There he goes. Put your foot out there to block it. The LiDAR will path plan around that. Yeah. It needs to be higher than 4 inches. But the idea here, there he is. He's path planning around it. He's trying. I'm going to blame the carpet. The carpet's kind of thick here. That's my excuse. But you can see again that he's got a map going there. He's attempting to make it to the other end of the room.
Nice.
Let's see if he keeps going along this path. So Ross was developed on a $500,000 robot called PR2, Personal Robot 2. Its claims to fame are it could plug itself in. It could actually fetch a beer from the refrigerator, the holy grail of robotics, and it could fold clothes. Of course, it took it 20 minutes per towel, but it could fold clothes. Anyways, all this software's been developed, distributed freely. The cool thing here is that you can now learn software developed for a $500,000 robot on your $400 vacuum cleaner. Okay, this one I built about 6 years ago. Here's Loco's trying to relocalize. Okay, he's spinning around. It's kind of silly with a sensor that senses in 360 degrees. But I'll let him try to figure out where he is. He's trying to get to the other room. The point I want to get at is that now you don't have to have a $1,000 computer velcroed on top of your robot. You can put this stuff on a Raspberry Pi and drop it in the dirt bin. Pi with a micro SD card sets you back about 50 bucks. We also show how to do this stuff at the SV Ross meetings, the penultimate Wednesdays at the Hacker Dojo. Everybody's on the mailing list, right? Right. Okay, great. So he's almost made it to this side of the room. Let's see how bad it is. Ugh. Oh, he's hopelessly lost. He thinks he's over here in the wall somewhere. Let me help the poor robot out. Again, I'm resetting the pose. So I click 2D pose estimate, and I estimate him to be right about here, facing that direction. Mouse up. The robot teleports there. And I'm going to set that goal one more time. Click. Boom. Let's set the goal much closer. How about that? I'm not proud. This is like poking the table bot. And I won't do this for much longer. Tell you what, I'm going to try to make it back to that end. That would be more better. So 2D nav goal, point, mouse, click, drag, and see the robot go in that direction. Go that way. So ROS was developed on the PR2, and that allows you to.
There you go.
Hang on, I'm going to reset his pose again. Well, actually, now he's going in the right direction. Let's see if he gets the podium there. So all this software is being given away free. The point again is that what ROS is basically in its essence is a publish and subscribe system. And so my bot vac here, the Nito robot, has a USB, and you can drive the wheels, you can read the LiDAR scans and stuff like that. And what's been done is that stuff's been taken and plugged into what is ROS, Robot Operating System, and it allows you to do the mapping and the navigation. You also get this wonderful visualization tool here, ROS Viz. And there you can see the robot is actually headed back to its goal. Okay.
My understanding is that the Nito vacuum cleaner is also capable of vacuuming.
Thank you, Mark. Just an added perk. Well, Mark brings up a good point. Is that there are many robot vacuum cleaners on the market today that you can choose from.
But you can't run ROS.
And there are tools that one could buy to learn how to program ROS. But there's really only one product that you can learn ROS and it vacuums. And that would be the Nito Bot Vac. So most any of the models will do that for you. If you need some help with it, let me know. I know a guy knows a guy, so we can help you out. Okay, so that's Locomo. That's the Floorbot challenge, kind of, sort of. Are there any other Floorbots out there? Alan Fetterman, Dr. Fetterman. Okay.
Okay.
Take it away.
This is also out of SV ROS. This is a Nito Bot Vac. We're using software from Ubiquity Robotics, specifically the SD card image to the Raspberry Pi 3, now the 3B. This is a 3. This is a minimally modified Nito Bot Vac, i.e. I can make it a vacuum cleaner if I want to. I'm doing the Floorbot challenge. In this case, the room is going to be, this is going to be one side of the room. This is going to be the other side of the room. My battery is critically low, so I had it on charger all day, honest.
Camera guy. Camera. Other way. The controls are backwards.
That one's mirrored.
Yeah.
That's not the right
So that's going to be the
watch
wall,
that one.
and I'm going to be the other wall.
No? The other.
Going around town.
The other left.
You got it.
Now it waits around 20 seconds, because the way I wrote this is I did a shell script that says go forward and stop, then turn left 90 degrees 2 times. Has trouble with that. And then it says go forward until you see another object and then turn around. So there's the first 90, which was like 95. There's the second 90, which was like 95. So when I'm on the wall, okay. Oh, I cheated it. I took my obstacle away too fast. Actually, I have this on video where I have my cat messing with it. But actually, that was a successful run. It's set so if there's a temporary object, it won't avoid it. Now, there's a deal with, Camp was running something called Move Base, which actually attempts to find its way around the obstacle. I'm running a light version of that called Move Basic, which does not attempt to find its way around the obstacle. If the obstacle is there and doesn't move, it gives up. So, give me the book. That's a successful Floorbot. And if you're out today, you have a joystick too.
Albergollis.
So you see this behavior here where it's going jerk, jerk? That's low battery.
Albergollis, ladies and gentlemen.
Dropping my equipment here. My robot is Cutie, which is on the floor. It's a Floorbot. Cutie actually has won an award for tabletop. With the proper table, it actually completes phase one just by putting it on the table, touching both ends simultaneously. And when if I couldn't do anything else, I could push a cube off the table. I could push a person off the table. If somebody hired me to build a hammer, I would probably spend the first 2 years or so writing an operating system for the hammer. So you can imagine what I might do to a robot. All right, I don't know how big this will get. What you are seeing now, okay, what you are seeing right now is what the robot is seeing. It's probably only the people in the front row, unfortunately. But I go to a lot of robot competitions. You know, 90% of the time they don't do what they're supposed to do, and I walk up to people's face and say, what went wrong? And generally speaking, I don't know. You know, the AI people have an answer. It needs more training. Most of us, the rest of the time, well, it did something, and I'll guess a few times. I am working on a solution to that. You know, I basically took a couple Ross classes, decided I didn't want to do that, and so I'm writing my own. What you are seeing right now is live video from the robot, what it's seeing. The little green dots you see are its line tracking algorithm. So it's looking for a red line.
Where is this happening?
It's way at the back.
Oh, it's actually happening in the back. Wow.
It is live, okay? This is my remote control. To prove it, hopefully nobody's quite in its way because you might break your ankle. I am moving. And you can see the image is moving. It's a little jerky because there's a lot of noise. It can only get so many frames. I'm not going to go back. While it's moving, you can't quite see it all because the print is so small. I'm getting immediate feedback on the screen here of GPS coordinates, IMU output. When I'm doing line following, I do a PID loop, and it's showing me the error, the integration, and the derivative, so I can, and if I look really fast, and it's also showing me its decision making. Those green lines are showing me where it thinks the line is. It shows me where it's steering. If I've got speed control enabled, it shows me all of that. And if there's then this little game. I'm trying to run the robot, and do I look at my screen to figure out what it's doing, or do I look up to make sure it doesn't kill somebody? What I'm going to demo, I'm going to just cheat a little bit. I'm going to move the robot. Nobody's in front of me. I'm going to move it completely away from the rope so you can see that's where it is. It's somewhere near the door. Okay, I ran a short little mission a while ago. Okay, while it's running, this is Ross-ish, and there are multiple nodes. Everything is written in Python. There's a message broker that's passing stuff between the nodes. All of that is being captured. When I go into a mission, which mission is just, I've got a scripting language, so this can run Floorbot, RoboMagellan, a whole bunch of stuff just by changing the script. When it starts a mission, it starts capturing those logs. And what I just got finished this week is the ability to save those under unique names and look at them. So I'm going to pull up, oh, I need to hit this. So I can Come on, don't do this to me. Ah. Okay, well, actually, ah. There is a fun thing that happens to me all the time, which is an OS X thing. OS X does all these nice things to make it feel responsible to a human and makes it non-responsive to computers. So I don't want to hold everybody. Okay. So I now have a list of missions that are on the robot. I can also transfer the whole thing to the MacBook so I can free up the space. And I'm going to play a mission. Hopefully I've got the right one. And this is a mission of the robot trying to follow the line. And it will go terribly off in a few seconds. And it's displaying all of that data. I just need a couple more lines of code and a little icon. I can step through frame by frame by frame and see exactly what it decided. Okay, the whole system is written in Python. All the code runs either on the MacBook or under Raspbian on the Raspberry Pis on the bot. So I've got a framework, just a little bit more code, to where I can run the analysis routines over here against the real data and compare that to the results from the bot. So I can do essentially a simulator, but I'm feeding in live data, the real data from previous missions. And so that's my toys. Hopefully not too long. It'll actually do something kind of useful, like run one of these things from end to end. But it's turned into a pretty nice developer's tool. Glad to talk to anybody about that if you're interested. It's got a lot of pretty cool capabilities.
Al Margalo is letting you go. Ralph Knock, ladies and gentlemen.
People who've been here before have obviously seen the robot a number of times. It's gone through, this is about third iteration of its existence. It's going to be a Floorbot, runs ROS. I've taken the Connect, it had a Connect off, and I'm currently, well, it's not working. I'm in the middle of putting a Nito LiDAR on it to do navigation. So I just put a regular camera back on it. Yeah. So it has a Jetson TK1 processor on it. It's all either laser cut or 3D printed to physically make it. Has a RoboClaw motor controller. So that's about it. So hopefully next month. It was that close last night to getting the laser with cables hanging, giving me data, but just haven't got it all assembled.
We appreciate your effort. Thank you very much.